This video covers section 6.3, factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 1. Objective 2, factor ax squared plus bx plus c, where a is not equal to 1, using trial and error. The trial and error method works really well when the a and the c are both prime. We will see that because a and c are both prime, we are not left with too many possibilities. So step 1 says, list the possibilities for the first terms of each binomial whose product is ax squared. Because it's a 3x squared, we are left with one possibility, 3x and x. Because it's prime, one possibility. Now we list the possibilities for the last terms of each binomial whose product is c. Because this is a 2, we can have plus 2 and plus 1, or we could have 3x plus 1 and x plus 2. Both of those two factorizations would lead us to 3x squared and the 2 on the end. We're just trying to find the one that leads us to 5 in the middle. I only chose the plus 2 plus 1 and the plus 1 plus 2 because I knew that it had to add up to 5 in the middle, or a positive 5 in the middle. So now we just check which one of these gives us 5. The first one gives us 3x squared plus 3x plus 2x plus 2. And that is the one that gives us 5x in the middle. The second one gives 3x squared plus 6x plus x plus 2, or 3x squared plus 7x plus 2. So this one is the error. We tried 2 and got one that worked. And so we get 3x plus 2 times x plus 1. So recapping on this one, list all the possibilities of getting a 3x squared. So we have 3x and x. Writing out all the possibilities for the last number, 2, 1, and 2. And then you have to write out all the different possibilities that you can get using those two, 3x plus 1 times x plus 2, or 3x plus 2 and x plus 1. And then you check which one of them actually gives you the 5 in the middle, and it was this one because 3x plus 2x is 5x. Practice 3. This leads me to your practice problem. I encourage you to press pause on your video and try this out. Trial and error works well on this one because of the a being 7 and the c being 3. Now that you've had a chance to work this out, I will work this out with you. In this case, a is 7, so we want to list the possibilities to get a 7y squared. We can have 7y and y. And because the c is 3, we can use 1 and 3, but a different factorization would be a 3 and a 1. Because we're adding up to a positive, we're going to use both positives in here. Now we check which of these actually gives us 22y in the middle. Both of these were set up so that we would have 7y squared plus 3. But the middle term's now 21y plus y. That gives us the 22 that we were after. The second one gives us 7y plus 3y, which is 10y. And that's the error. So we use 7y plus 1 times y plus 3. Example 5, factor the trinomial completely by trial and error. It is at this point when I start to get a little flustered with the trial and error method because now my a is prime, but my c is not prime. When I start to get too many possibilities, I like to go back to grouping. But let's attempt this one and show the possibilities. Because a is prime, it still leads us to a few possibilities. 3x and x. But now think about all the ways to get 12. 1 and 12, 2 and 6, and 3 and 4. So I try 1 and 12. But every one I try, I have to flip-flop them and use 12 and 1. Now I go on to 2 and 6. So I try 3x and 2, x and 6. And then I have to flip-flop them, 6 and 2. Now I go on to 3 and 4. 3x and 3, x and 4, 3x and 4, x and 3. They need to multiply to positive 12, but we need to add to negative 13. So I'm going to have to use the two negatives here. Now I have to check which of these give me the negative 13 in the middle. They all are going to give me 3x squared to start with. And then this one is going to give us negative 36x minus x. Plus 12. Well, that's definitely out of the question because that's negative 37x. The next one is going to be negative 3x minus 12x, and that's negative 15x. So that one's out of the question. Next one, negative 18x minus 2x is negative 20x. So we can strike that one out as well. Next one is negative 6x minus 6x. And that's negative 12x. And that one's out of the question as well. The next one is negative 12x minus 3x. which is negative 15x. Again, we're looking for negative 13. That one's out of the question. And then the last one is negative 9x minus 4x. And that's the one that does it for us. So we get the factorization, 3x minus 4 times x minus 3. And that's a little too much for me to do by trial and error. I personally think that it's a little faster to use grouping. Again, I repeat, trial and error works really well when A and C are both prime. When one or the other is not prime, that's when the grouping method is going to work well. So with the grouping method, we would use AC, 3 times 12, which is 36. That adds to negative 13. And we would look for our pair of numbers that have a product of 36 that adds to negative 13. Those two numbers are negative 9 and negative 4. We go back and factor by grouping by replacing the negative 13x with negative 9x minus 4x. From our first pair, we factor out a 3x. Dividing both terms by 3x, that gives us x minus 3. My second pair has a GCF of negative 4. Factoring out a negative 4 from both of those terms, I'm left with x minus 3. Common binomial of x minus 3, I factored off to the right-hand side, and we're left with 3x minus 4. So from here on out, if both my A and C are prime, I'm going to use trial and error. If one and or both of my A and C are not prime, then I'm going to use grouping. Example 6. Factor the trinomial completely by trial and error or by grouping, whichever one you find most suitable. In this case, I have AC that adds to B. The AC method is the grouping method. 4 times negative 6 is negative 24. That adds to negative 5. 1 and 24 doesn't work. 2 and 12. But 3 and 8 works. 1 needs to be negative and needs to add to negative 5. So we need the negative on the larger one, and then we get negative 5. When we factor by grouping, we replace the negative 5w with 3w minus 8w. We replace the negative 5w with positive 3w minus 8w. And now we factor by grouping. From the first pair, we factor out a w. Dividing by w, we get 4w plus 3. From the second pair, we factor out a negative 2. Dividing that by negative 2 leaves us with 4w. Dividing that by negative 2 leaves me with plus 3. Common binomial. We factor it off to the right-hand side. And we're left with W minus 2. Here is a list of things to use to help with the trial and error method. I don't really suggest going through this and figuring this all out. Again, I say that use trial and error when both A and C are prime. If one or both of A and C are not prime, then go ahead and use grouping. Here's a perfect example for grouping. If we were to attempt trial and error, the 12 could be 1 and 12, 2 and 6, 3 and 4, then breaking 35 up, 7, 5, 35 and 1, quite a few possibilities there. So I would rather use grouping. The grouping method, also known as the AC method, we take A times C, which is 12 times negative 35. Product of two numbers, that's 12 times negative 35. That adds or sums to B, which is 32. 35 times 12 is 420. Negative 420. That adds to 32. So we have a lot of numbers to try here. When I see 420, I think of 10 and 42. Putting the negative on the smaller one, that is the pair of numbers that will give us 32. Replacing 32y with negative 10y plus 42y. Now we factor by grouping. 12y squared minus 10y, we have a 2y in common. Dividing by 2y, we get 6y minus 5. 42y minus 35, we can factor out a 7. Dividing by 7 on both terms leaves us with 6y minus 5. We have a common binomial. Factor that off to the right-hand side, and we're left with 2y plus 7, giving us 2y plus 7 times 6y minus 5. Checking that. 2y times 6y is 12y squared. 2y times negative 5 is negative 10y. 7 times 6 is 42. And 7 times negative 5 is negative 35. Negative 10y plus 42y is 32y. Practice 4. This is for you to try. I encourage you to press pause on your video and work this out. And come back and press play when you want to see the solution. Now that you've had a chance to work this out, I'll work this out for you. You can use trial and error, or you could use grouping, whichever you prefer. On a problem like this, I prefer grouping, also known as the AC method. We take 12 times 6, which is 72, and we want two numbers whose product is 72. That sums to give us B, so we want the sum to be 17. So the product of two numbers, that's 72, that adds to 17. 1 and 72 is too big. 2 and 36 is too big. 3 and 24 is too large. 4 and 18 is too big. We're at 22 now. 4, 5, 6, and 12 puts us at 18. 6, 7, 8, and 9 puts us at the right spot, 17. 8 and 9 are our numbers, so we replace the 17x with 8x and 9x. And now we factor by grouping. From the first pair, we factor out a 4x. Dividing both terms by 4x gives us 3x plus 2. From the 9x and the 6, we factor out a 3, leaving us with 3x plus 2. We've produced the common binomial of 3x plus 2. We factored off to the right-hand side, and we're left with 4x plus 3. 4x plus 3 times 3x plus 2. Example 8. Factor the trinomial completely by trial and error or by grouping. $90x squared plus 21xy minus 6y squared. If I jump right into the AC method now, numbers will get kind of big. 90 times -6, -450. At second glance, I realized that the GCF here is 3. Taking a 3 out or factoring a 3 out from all of these terms will make my numbers 3 times smaller. Which in return, when I do the AC method now to factor the remaining trinomial, 30 times -2 is -60. So it makes that much smaller. And the sum needs to be 7. Product of two numbers is -60 that adds to 7. 1 and 60 is too big. 2 and 30 too large. 3 and 20. 4 and 15. One of these needs to be negative, and puts me at 11. 5 and 12. That's the pair of numbers that does it for us, -5 and 12. So we replace the 7xy with -5xy plus 12xy. And now we factor by grouping. 30x squared minus 5xy. We can factor out a 5x from both of those terms. Taking a 5x off the first one gives us a 6x, and a 5x off the second one leaves me with minus y. From the second pair, we can take off a 2y. That'll leave me with 6x. And a 2y off of that one will give us a minus y. We see a common binomial of 6x minus 6y. So we factor that off to the right-hand side. We'll be left with 5x plus 2y. And we can't forget about the original GCF of 3. So we get 3 times 5x plus 2y times 6x minus y. This leads me to your practice problem. I encourage you to press pause on your video and work this out, and come back and press play when you are done and want to see the solution. Now that you've had a chance to work this out, I will work this out with you. Two things. We have a GCF, but the leading term is negative. So I'm going to factor out a negative 3. Dividing the first term by negative 3 leaves me with 2x squared. Second term by negative 3 leaves me with plus x. And the third term by negative 3 leaves me with negative 15. Now we factor the remaining trinomial using the AC method. 2 times negative 15 is negative 30. That's my product. And the sum needs to be 1. Product of two numbers, that's negative 30, that adds to 1. Negative product means we need a positive and a negative, so it's really a difference. Two numbers whose difference is 1. Negative 5 and positive 6. So we replace the positive x with negative 5x plus 6x. And now we factor by grouping. From the first pair, we can take off an x, or factor out an x. Factoring an x off of 2x squared leaves me with 2x, and an x from a negative 5x leaves me with a minus 5. From the 6x minus 15, we can factor off a 3. Taking a 3 from a 6x leaves me with 2x, and factoring off a 3 from a negative 15 leaves me with a minus 5. Common binomial of 2x minus 5. We factor that off to the right-hand side, and that's going to leave me with x plus 3. And we can't forget about the original greatest common factor of negative 3, giving us negative 3 times x plus 3 times 2x minus 5. This concludes the video for section 6.3, factoring trinomials of the form ax squared plus bx plus c when a is not equal to 1. Objective 2, factor ax squared plus bx plus c when a is not equal to 1, using trial and error when appropriate, and grouping when trial and error is not appropriate.